we're going to make a important observation over here. It's relating the coefficients and the solution. So let's begin. We have three different cases. I have case 1 over here, 2 and 3 over here. So let's begin with case 1. First thing is the equation. It's in standard form. Then comparing with standard form, that is ax plus by plus c. So we need to get the coefficients of x, y and the constant written down so that we can take the ratios. So we have 1 over here, minus 10, 1x, minus 1y, minus 2. So a1 is 1, b1 is 1 and this is minus 10. a2 is 1, b2 is minus 1 and this is minus 2. So now when I take the ratio, what will I get? a1 by a2 is 1 by 1, b1 by b2 is 1 by minus 1, so that is nothing but minus 1 by 1, while c1 by c2 is minus 10 by minus 2, which reduces to plus 5 by 1. Now think about what kind of relationship all of these ratios have. So what is it? What did you observe? a1 by a2, right? It's not equal to b1 by b2, and that also any one of this is not equal to c1 by c2. That's your conclusion, is it not? So now let's look at the number of solution for such a scenario wherein the ratios are not equal to each other. Okay, so for that we need to generate our graph. We're not going to plot it, that is a different part altogether. So we are going to generate it. So okay, let me clear this. Yeah, so we have equation 1 to be green line, the red line happens to be equation 2. So we can see the line does cross each other at a particular point. Okay, and that is your solution. So how many solutions are there over here? Since there is since the lines are crossing only one point, so the number of solution is 1. You might ask, well, till now we have not seen more than one solution, is it not? So there was no other variation, so what's so special about this? So next two cases shows you that there are different variations. Oh yeah, there's one more thing that I would like to talk. Make constant sum same ratio. So what I want to do here is now I want to show a small variation. So instead of minus 2, I'll take minus 10. Then the ratio becomes minus 10 by minus 10, which is nothing but 1 by 1, which is same as, right, c1 by c2 is same as a1 by a1, sorry, a1 by a2. So I want to make this two same. Okay, so if I do make that same, what will happen? Oh, I actually made it same. So you saw all that already. So the first graph was supposed to be, my bad, minus 2. So this will be plus 2. After rearranging, it will be plus 2. So that graph actually is not that, this. Okay, so you can clearly see is the lines are crossing at a particular point around 4,6, right? So that was the actual question. And now the second scenario is wherein c1 by c2 is equal to a1 by a2, but even then the number of solution is 1. So let us change it to a scenario wherein it's equal to b1 by b2. So I'll make this as plus 10. So this is plus 10. So this will be minus 1. So b1 by b2 is equal to c1 by c2. So to do that, I need to change this to minus 10. Okay. And here too we can see that the lines are crossing one another. Okay. So if it's not clear that it is so, I need to change this. Then you'll get to see the answer. So you can see the lines are crossing each other. So whatever you do with C1 and C2, the lines will cross each other, provided A1 by A2 is not equal to B1 by B2. And the number of solution will always happen to be 1. Whatever you do with C1 and C2. So basically this, when you take small kids for playing, they just run around and you tell that even though the person is caught, he's not actually caught. I don't know how to put it across. So it's like if he's there or not there, it doesn't matter. Because if A1 by A2 is not equal to B1 by B2, by default the number of solution is 1. Okay. So the next variation is this, wherein we have x plus 1x plus 1y minus 10 being equal to 0, 1x plus 1y minus 2 being equal to 0. Then we have a plus b plus c. Compare that. We have a1 to be 1, b1 to be 1, and c1 to be minus 10. a2 is 1, b2 is 1, and c2 to be minus 2. Now the ratios are 1 by 1, and this 2 is 1 by 1, and this is minus 10 by minus 2, which is plus 5 by 1. Okay. So now please pause and think about the nature of ratios. Are they equal or not equal? So a1 by a2 is equal to b1 by b2, while both of this is not equal to c1 by c2. If so, what is the number of solution? To understand that, let's generate a graph with this condition. So let's do that. So we have this to be 1 and this is 10, 1 and 10, right? So when we transpose this, it will be x and the constant. It's minus x plus 10 and minus x plus 2. So this is correct. So if we generate the graph for this, we are looking at, what are we looking at? What kind of lines are this? Can you guess? If it's possible, you can take your protractor, I hope I'm right, protractor, and measure this angle and measure this angle. I'm 100% sure that these two angles will be equal. So what does it mean if those two angles are equal? Well, we have two lines and we have a transverse line. If the corresponding angles are equal, that means these two lines are parallel. So what is the conclusion? The conclusion is, if we have the ratios to be a1 by a2 being equal to b1 by b2, not being equal to c1 by c2, the lines are parallel, so the number of solution will be, can you guess? 0. Why 0 though? Because the lines will never cross. That's the whole idea of parallel line, right? That's the whole idea of parallel line, right? If the lines are parallel, they can never meet, and the number of solution is and will be 0. Then you might ask, sir, what if we change this ratio? What if we make it equal? That is your next case. Okay, so we'll look into that. So, but I would like to make one thing clear. See, it's not that A1, B1, A2, B2 have to be same. They can be different. What does that mean? Well, I'm changing A2 and B2 to be this 11, right? So A1 by A2 will be 1 by 11 because A2 is 11, and B2 again I've changed to 11. So B1 by B2 is 1 by 11. So clearly A1 by A2 is equal to B1 by B2, but it's not equal to C1 by C2. Okay, so let's look at that graph now. So I'm going to change this to 11. and what else, and b1 by b2 to be 11. So for that I need to divide with 11. Okay, because when I do that, let me show you why. So we have 11x, small not, 11x plus 11y minus 2 is equal to 0. So if I rearrange, 11x is equal to 11y is equal to minus 11x plus 2, and if I divide 11 both the sides, I have y is equal to minus 11x plus 2 divided by 11, minus 11x plus 2 divided by 11, right? So that's our equation, and let's see what happens. So here too we are seeing that the lines are parallel. Okay, so again, all that you need to know is the ratios have to be equal. Doesn't matter what are the coefficients exactly. The ratios are important. How are the coefficients related to one another? When in sense of a1 and a2, one is 1 and there is 11, they are obviously not equal. But the ratios of a1 by a2 and b1 by b2 are equal. That is important. Okay. So anyways, we'll be seeing a lot of questions. You'll have a better and clearer understanding, but hope you understood even now. The last case being when the ratios are all are equal. So let's have a look at that. I have the first equation to be 1x plus 1y minus 10 being equal to 0, 2x plus 2y minus 20 being equal to 0. So we have a1 to be 1, 1 minus 10, a2 is 2, b2 is 2 minus 20. Okay, c2 is minus 20. So we have the ratios to be 1 by 2, and b1 by b2 is 1 by 2 again. c1 by c2 is minus 10 by minus 20, which is plus 1 by 2. So you can clearly see the ratios are equal. So now, how will this graph look? For that, I have one more set of pair of equations down below. Right, same equation but rearranged so that we have y is equal to something and y is equal to something. Right, so let me execute, and we have the answer. So what is that we are looking at? Equation 1 is green and equation 2 is red but dashed. So we are looking at kind of some red and green. So what does it mean? And where is the other equation? Are these two the equation which we are supposed to look at? Is this a single equation line or double equation line? What do you guys think? See, one thing is the first equation never changed. From all the three cases, the first equation remains the same. So the graph had to have the first line had to be somewhere here itself. But we are looking at red and green combination, right? So what is happening over here? Well, the lines are overlapping. The lines are one on another. So here every point is common to both. So on a line we have infinite number of points, is it not? So the number of solution is infinite. Right? So basically if the ratios are equal, all are equal, the number of solution is infinite. Okay, I hope everything sank in. We have three different cases. One was wherein we had infinite solution, we had no solution, and we had one solution. For one solution we had the not equals to condition. In zero solution, that is when they are parallel, it's equals to not equals to, and we have third solution, both of them being equal. Right, so these are the three conditions, three cases. We'll see a few more examples, or actually a lot more questions based on this. and this is syllabus oriented, so you need to know this.